it's Sean from Tested. We are here with Mitch from Mosaic Manufacturing. We're going to talk about some multi-material FDM printing today. So, what'd you bring us?
I brought a lot of stuff. First of all, thank you for having me.
Yeah.
I think we met a little while ago, actually. We were showing Palette Plus, which was our first product in the market to allow almost any FDM printer to print in color. And now we're not just launching one product, but 4 products to create an ecosystem around printers that let them reliably print in multicolor, multi-material. So that's Palette 2, Palette 2 Pro, Canvas, and Canvas Hub, which I'll show you.
This guy. So just to give a little background for people who may not be familiar, a typical FDM printer, you do one material, one color at a time. We've been seeing more and more printers pop up now that are either dual head material, like dual head printers, right. Or even they have attachments that allow you to do multi-materials, and that typically either has multiple heads or some kind of switching between the filaments through the same head. So you guys have taken a little bit different approach with the palette. So why don't you just kind of start there and then we'll get into all the other stuff.
Absolutely, yeah. So when looking at something, a single color part, this would have started with an orange filament. I think I have some spliced filament there I can show you. So if you can imagine, just the beginning of this piece that's orange would have gone through the nozzle, like the glue gun on the printer, and made the orange part. What we do to create a multicolor part is that we actually attach together different filaments upstream of the nozzle, and we time the delivery of each of those pieces to the tip of the nozzle at the right moment, so that the same printer, which was before printing the single color part, is now making a really, really intricate multicolor part with the exact same resolution that the printer originally did, because it's the same nozzle.
Right. A novel approach. I have not seen anybody else tackling it this way. How did you guys decide, like when did you decide that you wanted to do a standalone thing that would work with anything versus a specialized printer?
Yeah, no, that was not an obvious thing. So yeah, to clarify, this is not our printer on the table. We don't make a 3D printer.
Right.
So it all kind of began when we were messing around with the printer. We wanted things in color, and we kind of realized, you could just feed different materials in one after another, and that way you could create a layer change. So maybe the bottom of the part would be white, the top would be black, and then we realized, wait a sec, what if we automated that and did it really quickly? The printer that we had in our desk, this is 5 years ago or so, could become a multicolor printer. And that's where the concept for seam technology, series-enabled extrusion of materials, which is what powers Palette, came from. And it's been a crazy journey of building the hardware to be reliable enough to make, really, really large prints.
Right. And
then the software to be able to time that all out and make it compatible with every printer.
Yeah, because not everybody, doing the multi-material things is a very complicated process. Typically, I've done a lot of multi-material back in the olden days of 2012, and so for something like this, you would need a separate model for the gray part, the pink part, the white part, and they'd all have to be brought in very carefully so that they're all in position to each other and they fuse together.
Yeah.
And that was always kind of a tricky thing. So, all right, can we take a look inside and see how this works exactly?
Absolutely. So we can take the cover off, just held on with magnets, revealing the whole inside.
Oh, this is cool. All right, so I see we have 4 different extruding mechanisms. And so why don't you go through how this works?
Absolutely. So the 4 filaments come in through the holes labeled on the bottom. Each one actually has an independent sensor, so if one ran out, we can have run-out detection and automatically switch to the next.
Great.
They then come up and merge at the cutter here. So this actually is able to slice the filaments. They then go up into the most important part of the system, the splice core. That's what heats up and cools down quickly to make those welds.
Right. So this is fascinating. So then we just have the main, this goes to whatever printer you're using. Now, can you, looks like you're using 1.75 right now. Do you have 3 1.75 or just the 1.75?
Just 1.75.
Okay. And can this be used with any printer that will take 1.75, or are there restrictions?
Almost every printer, there's 2 restrictions. The first one, 1.75. The second one being that the printer is able to work with most slicers, so the open slicers. So if it can work with Kira or Slicer or Simplify 3D, then it can work with Palette too.
That's great. All right. So once before we get into this fancy hardware, how is it doing this? How is it figuring out how long it needs to make each slice? And do you have your own special slicer, correct?
Yeah, so we have a slicer called Canvas, which is being released on Tuesday. So we're really excited about that. It's hosted up in the cloud. Anyone can make an account for free and get started and print. What's happening in Canvas is it has a full slicer. So it's taking a model, breaking it up into layer by layer, and creating the tool paths for your printer. What it also is doing is looking at the color changes or material changes, figuring out how long each segment needs to be, and then it sends that information over to Palette. So when Palette turns on and gets started, it knows, I need the first piece to be that long, and then orange needs to be that long, purple needs to be that long, and it does that for every single piece. Not only that, it's actually making corrections on the fly, because we all know sometimes printers will over-extrude, under-extrude.
Yes.
It's doing that the whole time to make sure that in a print like this, where you might have 1,500 splices, each one is going to arrive at exactly the right place.
Right. And I know traditionally, like you always had to, you get into the extrusion multiplier and all that kind of stuff and measuring your filament. Is that something you need to do with this? Is it like really sensitive that way to make sure that everything gets to be the right length, or is it pretty forgiving?
It's inherently sensitive, but we get past that by first saying, use your palette once you've tuned in your printer.
Yeah.
So once people have their printer tuned in, the first print you do with Palette 2, it's going to be a calibration print of sorts. So you're going to do your print. It's going to look at the value of how much filament were you supposed to use versus how much did it actually use, because there's a really a high precision encoder built into Palette 2. And then it's going to come up with a multiplier automatically and apply that for every print in the future. So we call it self-calibrating. And that's a big step up from Palette Plus, where you would have to do a dedicated hour-long print specifically for that. It couldn't be what you wanted, it had to be a specific model. That is completely gone with Palette 2. You just do your first print and it auto-calibrates.
Awesome. Well, do you want to start up a print and then we can continue to talk about how the ecosystem works?
Absolutely.
All right,
Let's
great.
do it. So Palette 2, you can see, is on the stand right now. So for a print, for most printers, you can just put it on a stand. It comes with different size tubes. You connect this to your extruder, you're good to go. With this printer right here, this is an example of a company that we're partnering with, Maker Gear,
right.
For an integrated experience. So this mount, which ships with Palette 2, is compatible with a bunch of printers. Maker Gear is one of them. So what I can show you is that we can take the stand off,
nice.
and we can actually just put it right on.
Yeah, I'll switch places here so you can get over there.
Perfect. We are going to connect a USB, which comes with Palette, which connects to the printer and connects into the side of the Palette 2. And then we're basically good to go.
Okay.
So I'll take out my computer and we'll start the print. Awesome. Okay, so I just hit start on the print.
Yeah.
And now the two systems are talking to each other. So the printer went into its homing position, and now Palette 2 is going to tell us what to do. So it says, load filament into input 1. So take the filament, I'll load it into 1. And what it's going to do is...
And obviously making sure you're getting the right color in what you assign.
Exactly.
That's where the human error can come in, I'm sure.
It can, yeah. So one thing we've done with Palette 2 is it's going to tell you what color to load, and it pulls that from your slicer.
Excellent. All right.
Yeah, so gray into drive 2.
So is it just using the sensor and then feeding it when it sees that the filament's there?
Exactly. We call it homing, just like your printer will home the axes. So now it's homed them, and it's going to completely take it away. So it knows that the first piece of the print we're going to do is going to be green. So it's passing through the piece of green. It's going to go all the way up.
See, it's going up, right?
It's going to go through this area.
This
and
is very cool.
So yeah, Maker Gear is an example of one of 6 companies that we're actually announcing that we're partnering with to create an integrated experience. So that loading that we just did manually, by working with the printer, it would be completely automated. Just one-click printing, and it would have been done.
Awesome. Okay, so what's this? What's it doing right here? This little loop right here.
Yeah, so this is called the buffer. What we're going to see is that in the buffer, the filament can go big or go much smaller, and that means that the printer can pull filament in at a rate that's different than Palette 2 makes it. It allows them to work together. So green's coming up here, but now Palette said, okay, it's time to go to the next color. So I think what's happening is it's splicing to white, and then we're going to soon see that white followed by green come through the buffer, and it's going to keep doing that for the remainder of the print.
That's very cool. So you already said you can do multi-materials as well. So I'm assuming, can you do flex materials, dissolvable supports, different colors, etc.?
All of the above.
Okay.
So yeah, because we've had Palette Pluses out there for a while, we sort of listened to what the most important materials for people are. So multicolor is a staple, being able to communicate things like stress on a model or actual text to distinguish between parts. And then when it comes to multi-material, it's a lot of functional stuff. So the spine, that was printed with a soluble support.
Right.
We have other type of breakaway supports. And then something like the Apple Watch band, which I'm actually wearing another version of this, you've got the flexible material to make it functional.
Nice, yeah.
And the rigid clasp there means that you can connect it in, and you get the function of having that snap fit.
Right, that's great. Yeah. So are there with that, are there restrictions on what materials you can splice together? Like, are there certain materials like not gonna splice, just not gonna work?
So Palette 2 actually creates a mechanical bond between filaments. So it isn't super picky about what materials you're using. It's actually the printers where you want to be careful. So a lot of material combinations that you would want to do, flexible and rigid, soluble and rigid, they work. But if you try to do something like nylon and PVA, where PVA's temperature would be 180, nylon would be 240, your extruder going hot and cold that fast
It's
isn't
not
going to
gonna
happen.
work. Got it.
So we try and say keep things plus or minus 10 degrees, and that's your printer's going to be able to handle that. And the good news is a lot of materials companies have tuned their materials to be in that 210, 220 range.
Yeah, there's not too many. That's a sweet spot. That seems to be so. In general, there's not going to be too many restrictions on what you can and cannot do as far as mixing stuff.
Right.
Now, the other thing that I want to talk about, what is it? Are we ready to go?
Yeah,
here?
so it's now waiting for us.
Let's continue with this then. All right.
Okay,
let's do
so
that.
what happened is it got to the end of the tube here, and the screen says feed filament into your printer's extruder. So we are going to load that into the extruder, and it's going to guide us through how to do this. So I'm going to pull up my laptop here so that we can go into the control of the printer and extrude. Maybe put this over here.
So I assume this would be a step that could vary a little bit depending on how your printer handles changing and loading filaments, stuff like that.
Exactly.
All right.
And so it's pretty generic. It basically says, so load into your extruder, next, clip your tube in. I just did that. Actually, I'll do it a little bit better. And then it says stop loading in 31 millimeters. So depending on how you control your printer, you would either enter in 31 or just keep extruding until that goes down to 0. We have control over here through Canvas, so I'm just going to say 31, extrude. And what it's doing is it's putting the end of that green filament right at the tip of the nozzle, so that when the print begins, it's all set.
So all your splicing measurements are right on.
Yep.
Okay.
So I just hit finish, and now it's going to start the print.
Awesome.
So that's all going to happen. I think there might be one more. Start your print, finish, and now it's telling me that it's 2 splices are done out of the rest of them. There's a progress bar. It'll keep track of all that for me. But those diagnostics are just nice to have. You don't have to really do anything. You just wait, and it'll print.
So let's get little Norm over here. So this is actually a really good example. This is one of my go-to torture tests. I've done a lot of multi-material, and white and black or any kind of light and dark combination was always a nightmare because you get the boogers. You know, so this looks really, really clean. The separation is great. So how are you dealing with like wiping things? Do you have a tower or a purge wall, or what are you guys doing?
Yes. So in Canvas, we will create what we call transition tower. But before I even get there, something that I might have skipped over before, something you wouldn't be used to, because we're doing it using a single nozzle. Those boogers or the ooze, there's no such thing. You're always printing, so there's no idle nozzle dripping through material.
Very good point. I didn't think of that way. You're right.
That's why we're not seeing, like, this is if I may say so, a perfectly clean white and a perfectly clean black, because the same nozzle was used. So there's no calibration of them, there's no dripping.
Yeah, so if we turn little Norm around here, I mean, it's clean. I'm really impressed by that. Yeah, that's great. So how are you guys dealing with the other stumbling block you get with the multi-material, even just with 2 colors, let alone 4, is how are you assigning the colors? Are there different models involved? Like, how is that working? What are you doing for slicing?
Yeah, so I'll show you in Canvas because it'll be the easiest way to explain that. But like the traditional workflow, what we're doing is this norm would have been 3 different models for this block. So the orange body would have been a model, all of the black bodies together would be a model, and then the white body. When you bring those into Canvas, Canvas says, oh, this is a multi-material print because I've got 3 models. It nests them together. And then in each layer, it's basically telling the printer and palette when it needs to change from orange to white to black, etc.
Right.
One thing I don't want to skip over, just to your question you asked a second ago, is dealing with that, the transitions between materials. We don't have any of those oozes, but what we do have is when you're going from white to black, you'll have a bit of a gray that comes out of the nozzle.
Right.
And
it's that transition, like a little leftover.
Exactly. To get a really clean print, we need to make sure we don't put that on the outside of the model. So we have a few options. We will soon be able to actually put that inside the model when possible.
Maybe it'll either do like a perimeter inside or infill or something like that?
Exactly.
Okay.
Or, because that's not always possible, for example, in this model, on the top surface we had black and blue. We wouldn't have been able to hide it anywhere because you'd be on the top.
Right.
So what we do is we create a transition tower. This is what a tower looks like. It is a structure that we print as efficiently as possible and as fast as possible. And you can see here it's going from gray to purple. So for every color change, we're going to do it off to the side on the transition tower. If you were doing 4 colors, this tower would get bigger and you'd have 4 of them.
Right.
One of our goals, based on customer feedback, of course, is try and reduce this as much as possible.
Sure, because that's part of what typically what takes a lot of times with the multi-material is like the purging, the towers, the wiping, like all that stuff. It adds to the print time.
100%, yeah. With the dual extruders, you've got the purge, the prime. With us, it's because we're continuously printing, there's no purge, but it's the transition priming.
Sure.
And so one cool thing we can do in Canvas, just as an example, is say something like this, where you've got blue, green, red, all in one layer.
Yeah.
If you were to go green, blue, red, every change, you're gonna have to go to the side and waste that material. So we do this thing called layer batching, where we found a way to check if we can do 4 layers of blue, 4 layers of green, 4 layers of red. And by doing so, you substantially reduce the print time and wasted material.
Right.
And that all can happen because we now have control over the slicer. So it becomes a lot more efficient.
So then with your calculations, and not only do you have to figure out the lengths for this, but I'm assuming you have to put in a certain amount of length to do the wiping process too.
We do.
So there's a lot of computing going on there.
Yes.
Okay.
100%. That's why this was. We always thought it was let's build a filament splicer. It was very much let's build a filament splicer, and then a humongous project equally as big was how do we build the software around this?
Yeah. Because that, I found a lot of times you get into the hardware is there and the software is terrible. So, yeah.
Yeah, and that actually basically describes what we'll talk about with Canvas, which is that with Palette Plus, we very much built a product to let people splice filaments and turn their printer into a multicolor printer. But what we heard is, okay, great, now my printer can do this. What the heck am I going to print? There were some models on Thingiverse, but it's a chicken and egg problem, So
yeah, so we should talk about that because if you haven't delved into the multi-material printing, the problem you're going to run into is that a lot of models that you download are going to be all one shell.
Yes.
So it means it's like one piece. So this norm won't have the separate glasses, the hair, et cetera. It'll just be all piece. And then you'd have to do a lot of post-processing work to break it back down into parts, which could be sometimes impossible to do or really, really time consuming. And then, where this mouth is, you have to have a hole cut that it fits into, et cetera. So it could be a lot of work.
Yes.
So what is your guys' approach to combating that?
Yeah. So kind of 2 ends of that problem. The first one is even today, when the models are broken out, actually coloring them in your slicer or colorizing them, assigning that this model should be orange,
Right.
That's a really challenging thing. And so we have a process where you just drag and drop color, you paint it, that's nice and easy. But that's in cases where you've already defined that the mouth is a different model.
Right.
If this was just a cube and we wanted to draw the glasses, what we are working on and will be coming out, don't have a date yet, but we are coming out with it in Canvas, is the ability to actually paint on a surface. So that can be text, that can be defining a vector, a pattern.
Oh, that's a really big deal.
It's insanely complex.
Because I'm just thinking on like, that's a really big. Now you can kind of do that with like Mesh Mixer. There's tutorials out there. Mesh Mixer, the free from Autodesk, that you can like paint surfaces or select surfaces of model and break them out into separate ones. But that is a really big deal because the problem you run into is that I can foresee is that let's say you paint the glasses on norm here. Unless these have a depth or thickness to them, it's going to end up being this kind of translucent black that all the white's going to show through. So when you paint, you have to have it automatically give it a certain amount of depth, right?
100%, yeah.
Okay.
The painting tool has to be coupled with the nature of how FDM printing works. And because we're in the slicer and Canvas, we have incredible power and control there to be able to make it all happen as one.
Well,
so
that is a huge step forward then. So in addition to, so you get the palette unit, comes with, I assume, the spool holder.
Yeah.
And why don't you talk about, we have a white and black version here. What are the differences between the two?
Yes. So this is Palette 2. Palette 2 is, the difference is really who it's meant for, who we built it for. So our customers kind of break up into 2 categories. Palette 2 was meant to be as accessible as possible while not compromising functionality, reliability, or any features. So it's the best palette we've ever built, but we were able to do it for $499 as a pre-seller, $599 regular. Palette 2 is mostly meant for people with printers that are below $1,000, so maybe your CR10s, your Robo 3D, your C2s, things like that. Hobbyists, education, that's who tends to typically say, hey, I really need it to be as accessible, as easy to use as possible, and as low cost as possible. Palette 2 Pro is aimed, like the name would suggest, at professionals. So these are people with printers that are typically much bigger, faster.
Right.
And they value uptime more than anything. So what they want is plenty of spare parts. They want a much longer warranty. We provide tubes for them that are bigger because their printer's probably bigger. And then one of the biggest differences that if we take the top off here, we can look at, the SpliceCore Pro here is an all-metal design. It's up to 20% faster than the traditional SpliceCore here. And so for those bigger professional printers who need the bigger speeds, especially with different materials, you get that with SpliceCore Pro. I can actually show you. So one big upgrade with Palette 2 design in general is that the SpliceCore is completely modular.
Oh,
so
great.
There you can hold the SpliceCore.
Okay, that alone. Yeah, because there's nothing worse than the terrible to fix extruders and jams and stuff like that. So that is a great step forward. So it sounds like the main difference between two is speed, reliability, and extended warranty.
Yes, and a few other parts. You got it. Yeah.
Excellent. Okay, Mitch. So one last thing that we have not talked about. What's this little doodad?
So this is Canvas Hub. Canvas Hub brings printers online that aren't able to connect to the internet, and it connects together Palette 2 with your printer to create a seamless connection. What that can unlock is one-click printing, so it'll automatically feed filament because it lets the two systems talk to each other.
Okay.
If your printer already has a Raspberry Pi in it, like the MakerGo M3, you don't need a Canvas Hub. But if you're using something that isn't online, like maybe a Prusa printer, you can use the Canvas Hub and it creates that integrated experience.
Awesome. And when is your projected? These are already out, right? Or are they about to be out?
They're about to be out.
Okay.
So the world finds out about these August 21st. That's when the pre-sale goes on.
Okay.
These are already in mass production, though. These are, in fact, pilots from the mass production run. So these are shipping at volume at the end of September.
Okay. And what's the prices on the different versions?
So the pre-sale price for Palette 2 is $499. The pre-sale price for Palette 2 Pro is $699. And then at retail, it's going to be $599 and $799.
Okay. And what about Canvas? How's that going to work? Is that just included with the thing? And is it backward compatible with the previous palettes?
It is backward compatible. In fact, it's a slicer that works even if you're doing single color. But it works especially well for multi-material. It's going to be freemium. So right now, completely free. And over time, we're going to be introducing a pricing package. But right now, it's just completely free.
Awesome. Mitch, thanks for bringing this in. I am really impressed with the engineering that went behind this. I can't wait to try it out. And we look forward to seeing this print finish so we can see how it looks. So
Thanks for having
me. Yeah.